And that's better. That's way better. That's much better.
Much better.
Moji moji.
Moshi moshi? Japanese?
Yeah, I think so.
Okay.
Sure. Yeah, talking loud again.
Ah.
Okay, sound test. Ah.
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 Okay, now we're done.
Okay, cool.
All right. Hey, good morning, everybody. It's Eugene and
Anne-Marie.
And we're here for Half Awake, Fully Caffeinated, episode Quattro. I'm seeing you count through your head.
I know, I was trying to think of it in another language.
Cats.
Wir.
What?
4.
For what was the languages?
French and German.
Kat. And what was it in German?
Wir.
Wir.
1, 2, 3, wir.
Russian?
No.
Interesting. So today we are talking about 4 different topics, per usual. 2 coffee, 2 non-coffee, and our coffee subjects are, my question was long black versus Americano.
And my coffee question was, tell me everything about the Maillard effect. It was a little more specific than that.
Yeah, and what it has to do
with coffee. Yeah.
There's a lot of, my questions are always loaded. It's not a single question. It's always got extra layers.
Yeah, no, I know.
Yeah. And then my non-coffee question was cryptids. And why are there some cryptids that proliferate cultures, that are in multiple cultures throughout the world, and to talk about one specific one.
And my question was CRISPR.
I love that question.
That was it.
Well, you gave me more information. You're gonna get us more information.
Yes.
Cool.
I studied.
Studied. So rock, paper, scissors again, or what do we want to do? You want to flip a coin?
Do we have a coin easily accessible?
Rock, paper, scissors it is.
Rock, paper, scissors it is.
And one, paper, scissors. Rock, paper, scissors.
Do you always go for rock?
No. I actually was thinking I should go for scissors, and then it ended with rock.
Okay.
It's one of those games where it's like you think
you think
too late after you've done something
I see.
Especially at 5 a.m.
You go first.
Which question though?
Let's get the annoying one out of the way.
Yeah, the annoying one. Long black versus Americano. And let's get our timer going. Whew. I'm tired. Also, my lower back is just...
Don't even talk to me about lower back pain.
Yeah, you're right. She just, for those of you that don't know, she fried off her. Okay, I'm on time. Long black versus Americano. That was me trying to actually burn a little bit of time because my answer is going to be relatively
like a 30-second.
It's kind of 30 seconds. I talked to Roz about it last night, and it was legitimately a 30-second answer to her. For those of you that don't know, Roz is my very loving wife. Long black is an espresso shot that is poured on top of hot water. And then Americano is an espresso shot poured first and then hot water added.
Can we do a taste test?
I mean, we're doing it right now. So I have an Americano.
I have a long black.
Anne-Marie has a long black. We can taste test if you'd like.
I'm just genuinely curious to see if there is a difference.
Okay, there's that.
There is. I taste a difference. I like mine better.
Yeah, yours is smoother, I feel like.
Yeah.
There's a couple of facts about the long black and Americano that I was able to pull through and get. The long black is going to taste a little bit more full. It's going to have a little bit more of a smoother flavor profile, a little bit more coffee forward. And it's because when you pour the espresso into the hot water, it preserves the crema quite a bit more. And then along with that, long blacks are usually a lower ratio of water to coffee, so it should be a little bit stronger. And the Americano is, I guess it's just the lesser, is what you would call it, especially if you're an American.
That tracks.
One person online when I was looking up what's the difference, what's the biggest difference, is that an Americano tastes, or the Americano has more freedom in its taste.
Fascinating.
But here's some history behind it. What's up?
I have a question, but you got to finish your 4 minutes.
Americano was made in Italy, and it originated a long time ago. And then a long black, this one's pretty interesting to me. A long black originated from New Zealand and or Australia. And the reason why they did that is because they figured that a long black would meet American taste buds and entice Americans to drink coffee at their shops. Because it's darker and it's
but Americanos
full coffee.
already existed.
Americanos already existed. Like
Right.
Americanos, like it's probably like hundreds of years ago.
Right.
And then long black in New Zealand, like I'm assuming.
So Americanos were not invented when in like World War I, when the American soldiers were in Europe and they tried making drip coffee, but they didn't like drip coffee, so they did Americanos or like something like that.
That's a really good question. I'm actually not entirely sure about the name behind Americano. That is on me. I will have to. Maybe that's something that we just start the next episode with, because I don't think it's entirely an answer that deserves 4 minutes.
I'm gonna go shut the door really quick.
Oh shit. Maybe we should restart that. For those of you that don't know, you can probably hear right now, that ice machine is horrendous.
I turned the ice machine off. That's just the ambient sounds of the shop.
Ambient sounds of the shop.
Yes.
But yeah, interesting fact, the Beanyard, to be completely frank, started with doing long blacks, but calling them Americanos, and then after we fixed that, we just never changed the name. So
There you go.
you're getting long blacks at the Beanyard,
You're
because we
getting long
want you to have a fuller coffee.
Yeah, it definitely tastes more alive.
Alive. Okay.
Cool.
All right. You had a question though.
My question was the Americano thing.
Okay. Cool. All right. Anne-Marie, you're up next.
I'm up next.
I'm gonna let you choose. I'm just gonna sit here and sip away.
Here's what I'm gonna do, is I'm gonna do Maillard effect and what it has to do with coffee. Thank you for coming to my seminar.
Maillard, are you ready?
I'm ready.
Good, go.
So the Maillard reaction, also known as the Maillard reaction, not just the effect, it is the accumulation of a bunch of small simultaneous reactions between sugars and proteins happening all at once at the same time in your food.
Cool. This is already a great answer. I'm enjoying this.
Don't worry, it gets better. And coffee beans, because it's related to coffee, and they're transformed by heat. So it's three things. It's heat, it's protein, and it's sugar. And then they have like a whole like little orgy together, and it creates more different proteins and sugars, because as the heat is going, it's breaking down the proteins and sugars, and those are making friends. And then the proteins and sugars that are now made from that are now making friends. And like, that's what the Maillard effect is. Just they're all up in each other.
It was too early for
You're
me
welcome.
on that one.
And it produces new flavors, aromas, and colors. So for two reasons, the Maillard effect is we're drawn to it. It is, first of all, the nutrition. It's telling our body that food will deliver easily and digestible food, calories, vitamins, minerals, all that fun stuff. And then the second reason is general harmlessness. We're gonna be pretty confident that the food's not gonna kill us because it's cooked. And it's not.
So the Maillard effect creates a flavor that makes you feel that.
And smell, yeah, smell and flavor.
Oh, okay, cool.
Yeah.
So we're biologically kind of
drawn
drawn to.
That's why a cooked steak smells better than a raw steak.
To you, I'm just kidding.
I mean, hey, you could like it blue. I don't know. So specific proteins and sugars will be all up in each other. Okay. This is a baby, but instead of a baby, it's aromas and flavors. Okay. So first step with Maillard is you have to dehydrate the dehydrate the surface, which kicks
the subject.
kicks in the browning phase, which is another way of describing the Maillard effect. And then certain proteins love bonding with reducing sugars, which is like simplified sugars. So the heat takes the complex sugars and reduces the sugars into simple, and then the proteins are like, meh, and then that's when the whole...
So the proteins feed on the sugar, or?
They just love becoming one with them.
Okay, so they meld.
They meld, hence the orgy. I'm sorry,
It's okay.
that's how it was explained to me, and it made the most sense. And
Yeah.
So it starts with a limited set of proteins and sugars, and then the more bonds that mix, the more proteins and sugars there are. So you're going to get more complex flavors and notes and everything like that. So for example, if you think of the humble potato, okay, when you roast it, you remove the water from the surface at first, and that allows the starches to open up and become more fluffy, and those starches break down into simple sugars. So it's starchy before, and then it's sugars and protein after.
I think this is a good spot where we should probably mention what the layman term for the Maillard effect is.
The browning phase.
Caramelization.
Caramelization. No! Ha! No!
It's not!
Ah! Ha! Ha!
Okay, get there, hurry.
Caramelization is...
17 seconds.
Okay, caramelization is there is more sugar than there is protein in the food. Maillard is where there's more protein than there is sugar in the food. It is simultaneously happening. It is just the way that the sugars and the proteins react.
So same stage, but different.
Same, but different.
Wow.
Damn it.
You can finish that last part.
With caramelization, there's more aromas and fewer flavor molecules. And with the Maillard, there are more flavor molecules and less aroma molecules. I got them backwards.
So caramelization has more flavors, yeah.
No.
Oh, you switched it on your notes.
Yeah, I got it backwards. Caramelization has more smell. It's more the aroma. And Maillard has more flavors.
Flavors. Cool. Anything else on that?
Sugar and water is hydrolysis.
Well, when you're like cooking down sugar to make syrup.
That is caramelization. It's the reaction between sugar and water. And the Maillard is the reaction between sugar and protein and heat.
Well, that one. Actually, I learned something today because I was always like, well, if you're cooking coffee, treat it like you're cooking onions.
Yeah.
But I think the principles stay the same. You want to dry it out. You want to break down the sugars. Not entirely break down the sugars. According to Anne-Marie, you want the sugars to have a...
Simplified. You want this to simplify the sugars.
You want the sugars to have a loving relationship and create more sugars.
More baby sugars.
More baby sugars. My baby sugars.
Baby sugars.
My baby sugars. Cool. That one's good. I like that one. That was a good question.
I feel like I saved myself from last week.
Yeah, you did. You did great. You did great.
Thank you.
All right, cryptids. So Anne-Marie asked specifically the lady in white, and I looked into the lady in white, and then I also looked into the Sasquatch, Bigfoot. Sasquatch or Bigfoot, Yeti.
Wait, the Yeti is the same thing?
Sasquatch, Bigfoot, Yeti. There's also others. Yowies, Habagan, Amphileathmore, Almasti, Amamungo. Starting with the white lady. So the white lady, as many of you might know, it's kind of like tragic female story. I don't know, maybe you guys don't know. Tragic female story, and usually the white lady is a sign.
I just gotta say, it's not a white lady, it's the lady in white. The white lady is just a generic white woman.
Sorry, the lady in white. I read like 17 different types of these, and some of the names like are translated directly to
As
the white lady.
The white lady.
And so, but the lady in white, correct. And you know, the lady in white, it's found in Germany, Germany, Britain, Japan. In Japan, they're called Onryo. And you know, it's prolific. There's a lot of stories of the white lady, and a lot of it has to deal with tragedy, super tragic circumstances for the lady. There was one story where it was about a woman whose husband was murdered by her father, so then she came back to hunt her father. There was another one where the husband abused her, and on his deathbed, he requested to be forgiven. And she said, hell nah.
Good.
And then he said, well, I curse thee. And then she became a cursed lady in the white. And then a lot of the times the lady in white has something along the lines of like her husband wanted something, she refused to give it. It's either sexual, non-sexual, that type of stuff. But she comes back, she haunts, and she's usually a precursor to more tragic things to come. So when the lady in white shows up, these things happen. So the next question about that is why? Why is this lady in white everywhere around the world? And I hate to say it, I think it's because the human consciousness is drawn to creating these types of narratives. There's a drama, like the drama of it. And then along with that, most women in all, like not most women, but most anyone in all cultures are usually buried in white.
Yes.
So there's, historically, not now, I think now you get kind of a nicer dress up. But
get a suit and tie.
I think along with that, there has to be something visually. Like when you see a ghost, you see white, you see black.
Yeah.
You see these visions, and I feel like at the end of the day, when you're seeing these types of things, whether or not it's real or not, that's up to your discretion, but light is what creates your ability to see what that is.
Right.
And so when you see light reflecting in a window or see something, especially at night, you just see white.
Yes.
You don't see any other colors, you just see white, and you see dark.
Uh-huh.
And so, in Japan, the Onryo, they're usually black hair, white garments, and same thing all around the world. And I believe it's because, this is my theory, gotta spend more time on it, but I believe it's because visually in the night, you see white, you see black. That's it.
Beautiful.
And then the Yetis are the dumbest answer, where it's like there quite literally probably was apes all around the world.
Oh, it was just monkeys or apes. Sorry.
Large apes.
Or large apes.
Yeah, I already gave you the names of them too, so that's the biggest thing. You can go dig on the apes yourselves. Yeah. You filthy animals. All right, CRISPR, and going in 3, 2, 1.
CRISPR. So CRISPR, otherwise known as, more specifically, CRISPR-Cas9, is a nucleus protein that acts wherever the guide RNA tells it to. Mm-hmm. So I had to give myself a whole high school biology DNA lesson.
I should have just given you the radio lab.
That's episode. Okay, because look, I even drew out the DNA strand to try and figure it out.
Dino DNA.
So basically, what I'm gonna break down is how CRISPR works. And then I'll go, if I have time, into what it does. But CRISPR essentially, so there's DNA, which is the 2 double helix, and then there's RNA, which is just a single of the helix. And this RNA is developed in a lab where scientists are like, you poke it a little bit and it's told to look this certain way. And then what that RNA is it's like a blueprint. So you show CRISPR this RNA blueprint, and it goes into your DNA, and it's like, okay, I found the bits in the DNA that are the same as the blueprint that they showed me. And then from that, we're like, okay, CRISPR, okay, Google, delete.
Delete or
add
yes.
or stop
or change variation.
Change, exactly. Yes. And so, it's just basically a way of editing your genes in a very, very specific and controlled way, which is super duper awesome for things like cancer treatment and immunity and things like that. However, they can sometimes fuck up. Not gonna lie, they can do that. That's something that the scientists are looking into and researching. But, oh my gosh, and it's gonna kill mosquitoes.
They're trying to, yeah.
They're trying to kill mosquitoes. with it. And that's my favorite thing about it so far. But I literally had to be like, okay, so there's a cell. And then in the cell is the nucleus. And in the nucleus is the chromosomes. And then in the chromosomes, that's where the DNA is. Mm-hmm. So it's like teeny tiny.
Super tiny.
It's teeny tiny.
Did you look into how they found CRISPR?
You know what? No, I didn't. This took a long time for me to get down.
It's not a bad thing. E. coli.
Oh.
So E. coli as a bacteria also fights viruses. And say if a virus attacks E. coli and then the E. coli beats it, the E. coli goes back and it's like, how did I beat it? It's like, this is what I did. And so then it goes back and edits its own DNA using what they have there to fight viruses in the future. So quite literally, this is a immunity or immune response from E. coli that we learned that it's doing. And we're like, hey, cool, let's take this and do it to ourselves.
Oh my God, humans are so smart.
It's crazy.
Hurts my brain.
But the effects are far reaching and wide because you get into CRISPR and you talk about fixing DNA.
Yeah.
And then you start realizing that DNA, as we get older, our bodies start getting worse at reading DNA because it's creating, so our bodies are really bad at creating proteins.
Okay.
And so as we get older, it gets worse, and then you just have these proteins that just gunk up all of the DNA, and so then you're just reading it poorly. So then that's why things like you start degenerating. That's why your hair starts going white. That's why you're like
There's too many proteins.
You're not recovering as quickly. Is that your body just gets gunked up? And so CRISPR, if you were to able to figure out.
But then that's the whole thing of genetically modifying yourself morally. Is that okay? Is that not okay?
And technically, like at the end of the day, fixing that issue is kind of fixing what is part of human life. And I think I don't entirely know if that's what we should be doing.
It led me to start reading the book Escape to Eden. It's not a good book. I'm not gonna lie. It's not a bad book. It's just I'm not the correct demographic and audience for that. It's for younger youths. Tweens.
Yeah.
But people in that book, they be real weird looking.
Yeah.
That's all I gotta say.
Super weird looking. Cool. All right. So let's talk about next subjects. I think you had a subject for me.
I do have a subject for you.
Gotta write these down.
That's a great idea. My coffee subject for you is tell me about anaerobic fermentation of green beans and just that whole world and why it makes coffee delicious.
Anaerobic fermentation. Cool. My coffee question for you is, let's see.
Excuse me. Sorry.
What is the relationship between water and coffee period?
Between water and coffee.
And to be further, because that's kind of a slightly vague question, how does it affect the brewing process?
Okay.
Actually, that's it.
Okay. I like that your questions are always double questions.
Well, because it's like water and coffee. You just talked about how if there's water in the coffee, you have to get rid of the water before you roast it, and then it can start getting the Maillard effect. True. No, this is specifically just for brewing.
Okay.
And there's multiple factors to it. I'm hoping that you understand.
Research.
You understand.
Yes.
Yes. Okay.
Do you have your non-coffee question for me?
I think because you were talking about proteins in coffee, I want to talk about the sugars. And there's a sugar in animal protein called alpha-gal.
Alpha-gal?
Alpha-gal, which I think is very interesting and very unique.
GAL?
Because you guys will find out.
Alpha-gal sugar.
Alpha-gal sugar. And then hopefully you find out the sad fact of what alpha-gal does if you run into the Lone Star tick. Okay.
My question to you is not sad.
It's not sad. It's
So-
just for
okay.
like it's for somebody that you'll find out. You'll figure
Okay.
it out. It's not like tragic.
Cool.
Unless if you love steak.
Okay, my question to you is, I feel like my questions are a little more like, ew,
Wispy.
and then your questions are like, science!
Yeah, I guess, we're trying to dig into things. We
Yeah.
could go cultural, like culture stuff
We
too.
could. So, but mine I feel like is going to be a decent one. Tell me, the moon.
The moon.
Does it affect more than just the tides? And if so, what and how? Werewolves. Vampires. No. Werewolves.
Werewolves. You're just trying to like bring in as much non-science things as possible.
No, everyone is going to think werewolves. When I say what does the moon affect, they say the tides and werewolves.
Is that what people say?
What do you think the moon affects?
My ability to see at night?
You know what I mean. You know what I mean.
I kind of get what you mean.
The gravitational pull of the moon affects the tides.
Oh, okay.
So that means that there must be a gravitational pull of the moon that it can affect something else, right?
Yeah. It just reminds me of, for those of you that haven't started watching Very Important People, you should start watching Very Important People and start with the alien interview because, do you remember?
Yes. Yes.
I get my energy from the sun and the moon. Well, technically the light from the moon comes from the sun, so you get the energy from the sun.
Yeah.
So, we get our energy from the sun, and if it comes from the moon, we'll take that too. Anyways, thank you guys so much for joining. Tell your friends, tell your family, and also don't forget to comment or, give us some stuff too. Again, there's going to be some contact information, hopefully.
Help me with my questions.
Yeah, and give us questions that you want to know about. Yeah. All right. Bye.
Bye.
There's that sniff.